Hello. In this video, we're going to look at the derivatives of sine and cosine functions, and we will also look at the derivative of tangent. But first, we're going to consider, before we get into formal definitions, of the graph of y equals sine x. So f of x equals sine x here. And we want to sketch what the derivative of this function would look like. So we know that when my original function has a maximum or minimum, the tangent would have a horizontal slope. So the derivative is going to have a value of 0 for each of these peaks and troughs, each of the maximum and minimum points for this sine function. So I'm expecting something periodic. If I think about when is the function increasing, so the function, for example, is increasing in this interval between negative pi over 2 and pi over 2, it's increasing in the interval between 3 pi over 2 and 5 pi over 2, between negative 5 pi over 2 and negative 3 pi over 2. In each of these intervals, because the function is increasing, I'm expecting to see a positive slope. So the slope needs to be above the y-axis. And if I consider what's happening, when would that slope sort of reach a maximum? It's going to kind of be in the middle here because there's a lot of symmetry. So the slope is getting steeper and steeper, but then it starts slowing down and going back towards 0. So the maximum slopes are going to occur at negative 2 pi, 0, and 2 pi. I don't know what that maximum slope is, but I do know that it's going to reach a maximum sort of airish. It's going to reach a maximum kind of whatever that is. I don't know what that value is, but it's a maximum. And similarly, I can expect that it's going to reach a minimum at negative 3 pi, at negative pi, at pi, at 3 pi, and so on. So what we can see is that this graph looks an awful like the graph of y equals cosine of x. Now there might be some amplitude change. I don't know where the maximum is, but I'm expecting that the derivative of sine is going to involve cosine in some way. So let's actually go back to our original definition, our first principles for how we can figure out the derivative of the sine function. So to find the derivative of sine of x, we use the limit as h approaches 0 of sine of x plus h minus sine of x, all divided by h. But we have some trigonometric identities that will allow us to manipulate this. Notably, the sine of x plus h is equal to the sine of x times the cosine of h plus the sine of h times the cosine of x. So this is what I now have as my new limit. I am going to split this into two limits. So I'm going to put these two terms together because they have a common factor of sine of x. So this is equal to the sine of x. Oh, I still have a limit as h approaches 0, of the sine of x times, if I factor that out, cosine of h minus 1 over h. And the sine of h over h times the cosine of x. So essentially, I've put those two terms that I highlighted in yellow together over h, and I've got the other term, the third term from the numerator, over h. The reason this is relevant is because these are my two special trig limits. The cosine of h minus 1 over h, well, the limit as h approaches 0 is 0. And the sine of h over h, the limit as h approaches 0, is 1. So what I end up having here for my derivative, the limit ends up being 0 plus 1 times cos x, so just cos x, which means that the derivative of sine of x with respect to x is, as we expected, the cosine of x. So you could do a similar graphical sort of approach to start figuring out, well, what would the derivative of cosine be? And it shouldn't be surprising that it's still going to be periodic, and we expect to see sine show up in it. But let's look at the formal algebra that leads us there. So we have this limit of h as h approaches 0 of cosine of x plus h equals minus cos x over h. And we have a angle sum identity for cosine as well. The cosine of x plus h is the cosine of x times the cosine of h, minus the sine of x times the sine of h, and then minus cosine of x, all over h. And just like we did before, we're going to group together the two terms that have the cosine of x as a common factor. So this is equal to the limit as h approaches 0 of cosine of x factored out of cosine of h minus 1 all over h minus the sine of x times the sine of h over h. And once again, we end up with the fact that we have our two special limits. The cosine of h minus 1 over h goes to 0 as h goes to 0, and the sine of h over h goes to 1 as h goes to 0. So what we end up with now is the cosine of x times 0 minus the sine of x times 1, which just simplifies to negative sine of x. So that means that the derivative of the cosine function with respect to x is negative sine of x. Finally, our third major trig ratio is tangent. And for this one, I actually don't need to go back to first principles because I can use the quotient rule. The derivative of tangent of x is equal to the derivative of sine of x over cosine of x with respect to x. So using my quotient rule, I derive the numerator first. The derivative of sine x is cos x, and I multiply that by the denominator, which is cos x. I now subtract the denominator, the numerator, times the derivative of the denominator, which is negative sine of x. And this is all over the denominator squared. So we get cos squared x plus sine squared x over cos squared x. But again, using a trigonometric identity, the cosine of x squared plus the sine of x squared is simply equal to 1. So this is equal to 1 over the cosine squared of x, which you will often see expressed as the secant squared of x, because 1 over cosine is the secant. So the derivative of the tangent of x is the secant squared of x. And those are your three primary trig ratios derivatives.